We have completed the GSM environment in our previous class, and today we are going to get into something called as GPRS. It stands for General Packet Radio Service. Basically, it stands for. So now, how this is going to be different from GSM? Is it different or is it something else? We will find out first that part. So stands for GPRS, General Packet Radio Service. So this is the overall architecture that we have studied so far, where mobile would be like trying to make some services. It will be requesting those services from this thing called as MSC, and we have the databases. What kind of services we can request that we already have studied, like registrations, location area updates, and CS calls, SMS, and USSD related services. These are all the different things that are possible in 2G environment. Now, from GMSC, there is an external network connected for us called as ISDN. From ISDN, you can reach several different types of networks, like public switch telephone network or public land mobile network, the other wireless networks, or we can even reach PDN. Now, for example, is it possible for a particular device over here, a computer here, which is having a ISDN number, can that computer make a call to your GSM mobile phone? Obviously, the answer is yes, it is possible, it is allowed. So, um, we can actually reach from the mobile device to a computer device which is having a ISDN number. So the only important criteria here is having the ISDN number. So that means um, if you take your landline phones, for example, if you take your landline, let us suppose that there are like 100 million landline phones are present. From the mobile equipment, we can reach any one of those 100 million landline phones. There is no kind of restriction. You can reach any phone, you can make a call, or vice versa. From any one of these 100 million mobile phones, you can make actually a call to this particular mobile phone possible. Similarly, if you take PLMNs, different operators will have PLMNs, and other mobile phones will be there. And of course, you can make a call to any of the mobile phone that is present in any PLMN. That is also possible. So you can make calls to any of the PLMN devices. For example, if you take that another 100, um, so if there is another 100 million mobile phones are here, you can even reach all those 100 million mobile phone from this mobile phone, because each of these mobile will have an unique ISDN number, and you can reach any mobile, or vice versa. You can reach from any mobile to this mobile phone. You can do that. So that means what can we clearly say here is this PSTN and PLMN are two systems which are completely integrated with ISDN. So you can reach any user or any device present in either PSTN or PLMN. We can reach from this particular mobile. We could do that. So that possibility is there. Okay, great. Then what about the PDN? Now, if you take that in the PDN, there are like another 100 million computers are present. But if 100 million computers are present, or maybe like maybe 1 lakh servers are present, you can consider PDN containing different things like individual computers and servers. Now, from your mobile phone in the GSM architecture we have studied so far, can you reach all those 100 million computers and 1 lakh servers? Is it possible? Now, the answer is no. You cannot reach all those computers and all those servers with the help of ISDN. Like, why? Why not? Because already PDN is connected to ISDN. So, why can't we reach all the computers present in the PDN or all the servers present in the PDN? When that possibility is there for PSTN devices and PLMN devices. The primary idea of the PLMN devices and PSTN devices is each and every device in either PSTN or PLMN, they have a ISDN number available. Because of that, so you can reach any of these devices, any of the landline phones or any of your mobile phones you can reach. But on contrary to that, your packet data network, if we are assuming that some X number of computers are there and some Y number of servers are present in your PDN, you cannot reach all those X number of computers or Y number of servers that are present in the PDN. Why it is not possible? The biggest obstacle is all these systems that are present in your PDN, they won't have the ISDN number availability. They won't have the ISDN number. Only few systems. Let us take that maybe out of the many millions of systems that are present here in the PDN, let us suppose that 500,000 devices are containing the ISDN numbers. Now, if half a million devices are containing ISDN numbers, only those half a million devices can be integrated with your ISDN, and they can make the calls to landline or they can make the calls to other PLMNs or to our PLMN. They can make the calls. Only those half million computers which are having the ISDN number. Then what about the remaining servers and remaining systems which doesn't have the ISDN number availability? So those devices are obviously secluded, and you won't be able to make a call to that device. For example, you have a normal computer connected to internet, you cannot make a call to that computer from your mobile phone until and unless the computer is having any kind of specialized applications which are getting integrated with ISDN, your integrated services digital network. So the only option is computer connecting to the ISDN. But the rule is, if any system need to be connected to ISDN, the system must first procure a ISDN number. So they won't be allocating ISDN numbers individually for the computers. Typically, they would be allocating ISDN numbers for companies' customers when a company buys a huge number of ISDN numbers. So you are operating as a client of a company. Then, if that company is procuring a lot of ISDN numbers, then all the computers that belongs to that company might have the feasibility to be able to communicate with the ISDN systems, and we can make the calls to any PSTN or any PLMN or any other mobile user present anywhere. Okay, so all these possibilities are there. But the obvious question is, if only a small portion of PDN are now reachable through this ISDN, what about the remaining portion of PDNs? What if from this mobile we would like to get some server information in the PDN, like we wanted to directly communicate with the server and we wanted to gather some information from the server. So then what you should do, can you contact the server with the help of the ISDN? And the answer is no, you cannot contact the server, because here server is not the one which is having a ISDN number. So you can never contact that server and gather whatever the information that you want through this ISDN network. Later, what they have done. So that means maybe even if 1% of the entire PDNs, if 1% of the entire PDN systems containing ISDN numbers, That means from your GSM mobile phone only we can reach those 1% of the computers to make the calls. The remaining 99% are still basically outcast here. So you cannot reach those 99% of the devices. Later, what they started implementing is a mechanism called as your, um, what do we call USSD server. So unstructured supplementary service data. So what do they do is they will give internet capability to this unstructured supplementary data server, and with the help of that internet capability, maybe your USSD server can actually communicate with a small portion of the PDN devices and gather the information and store it into this USSD server. So when mobile user have sent a request like *141# or something like that, when they are actually sending some kind of a USSD request, that USSD request will be forwarded to USSD server. The USSD server, which has already fetched the information from the internet servers, it is storing that details, and we forward that stored information to your mobile phone. That means that with the help of this USSD architecture, the unstructured supplementary services architecture, data architecture, we could reach another small part of your PDN servers. Now let us take that this is another 1%. Just telling the numbers. It is not the reality, but just telling the numbers. So 1% of the systems are having ISDN numbers. We can reach those 1% of the systems. Another 1% of the systems are pushing their information into USSD server, and the mobile users will be able to dial something called as USSD codes, and they will be able to extract this information that these internet servers are maintaining, but not directly, but indirectly. But even in that particular, even if we think that both the things are perfectly working, so ISDN helping you to reach 1% PDN systems, we are reaching with the help of USSD another 1% systems. What about the remaining 98% of the systems? um, you are still not touching those 98% of the systems. That means a big network called as PDN, packet data network, which is containing lakhs and crores of computers and servers, is not accessible to your mobile devices because of the limitations of the GSM architecture, as your GSM architecture is only helping you to connect to the systems, PDN devices, which are having either ISDN numbers or the PDN systems, which are actually like having a interconnectivity with the USSD server. But this interconnectivity with the USSD server is not like mandatory. It is like operator decided. Operator thinks what are the popular internet-based services that are out there in the world. Only operator decides to bring the information from those popular internet servers and store that information into this USSD server and provide those details to the users who are typing some USSD code. So we will be sending. But what about unpopular servers? If you are only bringing the information from the popular servers, it is fine. But what about unpopular server? Maybe you might be getting the cricket score, because cricket is popular in a country, so you can get the cricket score, get it from a internet server which is maintaining the cricket score. It is coming and getting stored into your USSD server. By dialing some number, you will get that cricket score to your mobile. Fine. That means indirectly you are able to reach this cricket internet server. You are reaching the cricket internet server which is maintaining the cricket score, and you are gathering the required details. You are obviously doing it. But what about the not so popular things? For example, there is a local newspaper in a in a particular state may not be popular. It is only popular among say a few people, few one section of the society. If they wanted to access, because operator is not providing that news collected by that particular news station or newspaper company, so USSD service is not available. So nobody is collecting that news from that particular news service station because the data is not available in USSD. Now your mobile phone, the human being, if you wanted to get that data, now there is no possibility to get that news information because USSD is not helping you. You cannot reach that news server through ISDN because your internet-based news servers won't be having ISDN number allocated. So you don't have ISDN number, and there is no linking between that server to USSD server. So the moment you don't have both, you do neither have a ISDN number nor have a connectivity to the USSD. Now this particular news server is outcasted. We can never. There is no way we can connect that news server. Okay, so this is the limitation of the GSM network. So they are telling that even though we are providing the PDN connectivity through ISDN, we are not able to reach every PDN system because there are only few PDN systems which are following the ISDN numbering scheme. Or even if you are having a USSD server, that USSD server also is bringing the data from only from limited PDN based servers, not all the servers. If you want to get the data from all the servers, it is impossible because the number of servers we'll be having will be in crores and you know like even more than crores. Crores of servers will be there worldwide. So if you need to bring the data from every server and store it into USSD server, that is impossible. So there is no way you can reach a major portion of your PDN network. So they started thinking we must actually think over it and solve this problem and let the mobile users connect to the remaining portion of the PDN network, packet data network, without having any kind of a restrictions. So, irrespective of which PDN computer the mobile would like to communicate with or send the data to, or whichever server the mobile equipment would like to communicate with the PDN, we must be able to provide such a service to this mobile phone. We must do it. So that was the thinking process as the traditional GSM architecture is not providing any kind of an activity. It is not providing anything at all, obviously. So, how did they do it? How they have made the mobile connected to this PDN, packet data network, um, to solve this problem that we are having of partial reachability to the PDN, okay, with the traditional GSM architecture. Question from Jagannath is if you want to reach USSD, is it only by GSM or is it possible from LTE, VoLTE mode? Actually, USSD was very popular earlier, but USSD is not so much popular nowadays because anything you want to check, you have an internet application available. You can connect to the corresponding internet servers and get it. So there is no need to use USSD information because USSD information is not your refined data. What is the meaning of not refined data? For example, you have to like let's suppose this. Um, for example, you wanted to you wanted to watch Cricinfo website and watch the cricket score. What does the Cricinfo website actually do? Is what is the Cricinfo website actually do is they will present all the cricket related scores, etc., etc. It will be presenting everything in a what do we call it, in a beautiful format. Now, when you actually can reach the Cricinfo website directly from your mobile phone, you will be able to see all the information that the Cricinfo server is maintaining in a perfectly presented manner that you may like it. But the moment you wanted to get the same cricket score from a USSD server, it is all refined information. Your USSD server won't be presenting the information to you in the same format that the Cricinfo website is displaying it or showing it to you. So when you ask by typing some code like a USSD code, for example, you have typed 141 hash, you want cricket score. You will get the cricket score, quick cricket score, but it is just a text information which says the major details about your cricket score, like what is the present score, which are the batsmen playing, and how many overs completed. That's the major information the USSD can bring you in the form of SMS. So the complete presentation is dead, and you are getting refined information from the server. We don't want that. So because USSD is not providing you the service as it is providing a deviated service. In the earlier days, because when there is nothing available, USSD was like a really god. Because at least some information you will be able to gather with the help of USSD servers, wherever the operator is maintaining connectivity between the USSD servers and different popular internet-based services. Operator can bring a lot of possible information to USSD servers, and when you're requesting from that subset of information which operator is maintaining in their USSD servers, as long as you are requesting only that much, you can get that information and you will be feel happy about it. But is it the same thing that you wanted to be you wanted it to be presented in the same way? You never wanted it in that way. You wanted it to be presented in a better way. So USSD is not the modern day mechanism. It was invented in GSM. It died along with GSM. So we never need to use USSD in LTE. So the question is it possible in LTE? Obviously, it is possible in LTE. Why it is possible in LTE? If it is really, if 3GPP has implemented that, it would have been possible. But does the 3GPP implemented it? The answer is hell no. Why not? 3GPP said that, hey, why are we doing this? Okay, this is not required. For example, um, there are like a lot of modern um, you know car engines are available. For example, if already lot of car engines are available, do you try to go and try to use a car engine model from 1960s? You won't do that because they are not fuel efficient, and they are designed for that generation, not for today's generation. When you can directly contact any internet server and any information directly, there is no point in talking about USSD, because USSD proposing that getting that internet information and storing it in a operator format and sending it in a very small kind of information to the user is not a great idea. So it is no point in implementing that. Okay, so that's
Sir,
the
why I am
idea here.
asking this is, sir, why I am asking this is, now I'm in LTE mode. If I type some codes, LTE and voltage goes off, and so for a moment it goes off, and once I get message, it will recording. So that's why. So it's USSD means it's go to
It
DSM
might
only, I
happen.
think.
See, when you type this
Might.
kind of a
Mm.
USSD string, you might move out of LTE network and go into old network and execute that USSD command. And once the execution is completed, you may come back into LTE network once again, just like how Vivo LTE thing is working. But the point I'm trying to tell you is, in LTE, it was never implemented. We have to consider right now the implementation belongs to your old technology only, like your GSM, GPRS technology only. Reason is Mobile, when you type any USSD by force, when you try to do any action by force, mobile will leave LTE network and it automatically goes into the old technology network and start doing its tasks. So in old network, so we cannot consider that as a LTE technology because you yourself going into the old technology. It is definitely your old technology solution. That is the way. Okay. All right. What is the use of the interfaces, Ravindra? I'll answer your question later. Just hold on to that. Okay. Now, so they started implementing this new technology called as GPRS, General Packet Radio Service, which is allowing us to connect to packet networks directly. So one additional service system integrated directly. So which is that additional service system getting integrated directly? PDN stands for Packet Data Network. Like example is internet is your biggest PDN that is there in the world. So you are connecting to an internet PDN with the help of GPRS network. But to implement this GPRS technology, they needed some new components. So actually, there were three components introduced for helping out the mobiles who would like to connect to the PDN directly. So the first component among that is packet control unit. So what does this packet control unit do? It is going to take care of radio resource allocations for packet services. So whenever any mobile equipment requires radio resources for circuit switched services like CS calls or sending SMS, etc., the resources would be allocated by your BSC. But whenever the mobile wanted to utilize packet services, like wanted to connect to the packet network and perform the packet service related activities, that time who must allocate the radio resources is this PCU, stands for Packet Control Unit. Now, um, this was the original idea, like this packet control unit, introducing a separate radio component which is taking care of radio resource allocation for GPRS. So, but later what they have done is they have integrated this why they have introduced a new component, why they did not implement all the radio mechanisms in BSC in the original days. They thought that um, they don't know whether this GPRS technology is going to be successful or not because they are not sure about the success of this technology. They wanted to develop everything separately. So if it becomes unsuccessful, they wanted to take it out. That is why in the earlier days, they have implemented the complete GPRS technology in separate hardware entities. So one of the hardware entity which is taking care of radio resource allocations for packet services is your PCU. PCU will be there almost along with your BSC, but as BSC is accepting the request for CS services, this PCU would be accepting the radio resource allocation request for packet services. That was the idea. But later, what happened is because the GPRS has become so popular, people started connecting their mobile phones to the networks. So obviously it became popular and popular every day in and out. So what started happening is they started thinking that why we have to keep this PCU separately, we will integrate this PCU functionality also into your BSC itself, your base station controller itself. So they have made base station controller containing both functionalities like radio resource allocation for circuit switcher services as well as radio resource allocation for packet switcher services. Everything is going to be done by your BSC itself. That means the idea of this packet control unit is the starting days. What I'm trying to tell you is later it has got collapsed or it has got integrated into BSC. So um, so there is no packet control unit in the modern day GPRS networks, as the integration of this logical unit already took place into your BSC itself. Okay. But there are two more components that are introduced for GPRS, but nothing happened to these components. These components stayed as it is. First component is called as SGSN, stands for
Hello,
yes,
excuse me, sir.
yes.
Now you are a screen not showing. No?
Sorry,
A screen is not showing. You are showing a screen or not?
I'm showing the screen. If you are not getting
But
the screen,
I am not visible.
okay. If you are not able to see the screen, you quit once and come back to the meeting once again. So sometimes your mobile problem or device problem will happen. So you quit your meeting and come back to it. You will be able to see the screen. I am sharing the screen already.
Actually, I'm not visible. That's why I'm asking.
You leave
Okay,
the
okay,
meeting. You leave the meeting. Come back again. Okay.
okay, okay, sir.
Okay. So the component that we have introduced is SGSN, stands for Serving GPRS Support Node. So what is this component? What does it do? It is almost like performing the functionalities like a MSC. MSC is the service authorization component for your CS services, circuit switcher services, whereas your SGSN is the service authorization component for packet switcher services. Okay, so it is the service authorization component for packet services. That means if mobile requires any CS services, mobile need to request it from MSC. But when mobile requires any packet PDN based services, packet data network related services, mobile must request those services from SGSN. So what does SGSN do? Whenever you send a packet service request to SGSN, SGSN will try to authenticate whether the user is genuine or not. If the user is genuine, then SGSN starts accepting that service request and provide you that services. So in CS network, it is the MSC who is accepting your services. In PS network, in packet switch network, it is the SGSN who is going to accept your services. That is the differentiation. And the last component that is introduced in GPRS network is called as GGSN, stands for Gateway GPRS Support Node. So what does this guy do? Gateway node is going to perform. It is a gateway node to connect external network called as PDN, Packet Data Network. If you remember our gateway that we have in the CS network, gateway is connecting to the ISDN network in in GSM infrastructure. But in case of your PS network, your gateway GPRS support node GGSN is directly connecting you to the external network called as PDN directly. We are not connected to the ISDN. We'll directly connect it to the PDN. Another two jobs that will be taken up by GGSN is it will be allocating IP addresses for the mobile phones, all the mobiles which are connecting to the packet data network. They must have an IP address to interact with the IP technology components like your computers or servers. If you want to interact with those kind of systems, you must have an IP address. So who allocates the IP address for the mobile is your GGSN. One more interesting thing that the GGSN performs is billing. It will be counting the number of bytes of data that you are transporting into the PDN, or number of bytes of data that you are downloading from the PDN packet data network, you will be counting the number of bytes. So, and that is the billing activity. For example, if you take up a service from one operator like 1 GB per day package you have taken for your mobile, now somebody would be counting how many bytes of data that you are sending. Who is that somebody? In your Gprs network, that component is GGSN, Gateway Gprs Support Node, who would be counting how many bytes of data you have downloaded, you have uploaded, total together, how much. Once you reach your maximum size, after that your speed will be reduced, or you will be denied connecting to the packet data network, nothing but your internet majorly will be denying that. So such kind of activities will be taken up by this GGSM. Now, where do you fit these three components? How the network would look like in case of GPRS? How the network is really looking like? Um, so your PCU is almost, it is kept inside your BSC. So packet control unit is now lying inside BSC. It is not a separate component anymore. Then we have our SGSN and GGSN, and SGSN will have this VLR connectivity to store the subscriber data that SGSN is procuring from the HLR. Now, if the mobile is trying to do a registration, now mobile can do two types of registrations. Mobile can do registration with MSC, mobile can do registration with SGSN. When mobile is performing a registration with MSC, MSC will go and talk to HLR, gather all the CS service related information, CS services. Which are the CS services? Yesterday we have studied those CS services. Your call, SMS, you have your USSD services. These are all typically would be called as CS services. So which and all different types of services you have subscribed, that information HLR pulls it, and MSC will pull it from HLR, and MSC stores that subscriber information into your VLR. It will be storing it into the VLR, into his VLR. But when the mobile is trying to do a registration with your SGSN, um, you you try to do the registration with SGSN whenever you want to have a PDN connectivity. When you want to connect directly to the PDN, you want to reach that servers and computers that are present in your PDN from your mobile phone. That time, what does SGSN do is it goes and speaks to HLR, gather the user subscriber details, and store that subscriber details into VLR. This subscriber details are related to PS services, like uh, like what kind of data services you can have. It is all about that data services related information. So SGSN will gather that details from HLR, store that information into its own VLR. Um, so just like how a MSC is having a VLR, its own pet database to store its subscriber details, just like that, your mobile phones, your SGSN also will be having a VLR to store the information of the mobile phones who are registering with him. Okay, so if a mobile registers with SGSN, it will gather the details from HLR. If mobile registers with MSC, the MSC will gather the information from the HLR and store it. So, what happens after this? Um, Now, mobile first requested for the radio resources from your BSC. BSC allocated him some SDCCH slots. So after that, what happens? After SDCCH slots are allocated, mobile sends some request to BSC. Now, what is the duty of the BSC? BSC need to detect whether it is a CS request or it is a PS request. You need to classify that. So BSC classifies the message as a CS message or a PS message, and depending on the decision, if it is a CS request, BSC will forward that to MSC. But if it is a PS request, BSC will forward that to SGSN. So BSC is some kind of a separator of your different kinds of signaling messages that are getting originated on the mobile station. If they are related to CS services, you need to forward it to MSC, because CS service authorization component for you in this network architecture is MSC. PS service authorization component for you is SGSN. You must register with SGSN for PS services. It's like that. Um, so once mobiles,
Hello.
yes.
Excuse me, sir. I have a question.
Hmm.
Sir, if you request for PSS services, in that case, authentication verification is not happen.
There will be a
It's happened.
yes, authentication would be
Authentication verification
there.
will be happened or not?
Yes, it will happen. Same things will
So direct
happen.
you
Even
come to
SGSN actually can go and gather the authentication details from the authentication center, challenge the mobile by sending an authentication request by sending random number, ask the
without
mobile equipment who
sending request to sir. Let me speak.
yeah.
Sir, without sending a request to MSC, how it will authentication request is happened in case of PS?
MSC is not God here. MSC is just like any other component. MSC is just like another component like SGSN. There is no speciality of MSC. There is no speciality of SGSN. Here, these are two hardware plus software components which can communicate with the other network elements. So MSC can go and talk to authentication center, gather the subscribe authentication details. By using that authentication details, it can challenge the mobile. Just like that, when mobile try to register with SGSN, SGSN can go and talk to authentication center, gather the authentication details. With the help of the details, it can challenge the mobile and ask the mobile, "Are you a genuine guy or not? If not, I will not accept your services. Prove me that you are a genuine guy."
It means SGSN is here is working like a MSC, right?
Just like a MSC. That is what I told you when I have used the terminology.
Okay.
Try to listen to the terminology.
Okay, I got it.
You got the
sir.
point. I will tell you the terminology right now. Okay, terminology is very
Okay.
important. Um, what is the terminology? MSC is a CS service authorization component. Listen to that words. Service authorization component. Similarly, your SGSN is PS service authorization component. PS service authorization component. What is the difference? If you require any bloody CS services, you need to authorize with the MSC. Then only MSC will accept those CS services. Similarly, if you need any PS services, you need to get the authorization from SGSN. That's the difference. Are you getting it? So these are like two equal components. MSC and SGSN are two equal components. One component is working for one kind of services. That way. So once a mobile user successfully convinces SGSN to give him his services, um, that time SGSN will go and speak to GGSN and ask GGSN that, hey man, so-and-so user wanted to connect to the PDN. Can you please allocate IP address for this particular mobile phone? And GGSN allocates that IP address, give that IP address details to SGSN. SGSN will forward that IP address information to your mobile phone. Tell the mobile that if at all you are generating any application data, for example, if you are using WhatsApp and you are generating a WhatsApp message, for this WhatsApp message, you need to pack that WhatsApp message into a IP packet. In this IP packet, you must have a source IP address, you must have a destination IP address. The source IP address must be mobile equipment's IP address that is allocated by GGSN. This IP address, whatever that is allocated by GGSN, that IP address will be quoted as source IP address. This is the mobile's IP address. Destination IP address for this IP packet is going to be your WhatsApp server's IP address. So WhatsApp server is present in somewhere in the packet data network. It has got an IP address. Somehow technically mobile will find out what is the IP address of WhatsApp server, and it will be including that IP address as the destination IP address. So by packing your WhatsApp message into a IP packet, in the IP packet we'll be adding two headers: source IP address and destination IP address. Source IP address is your mobile's IP address. Destination IP address is your application server's IP address. Once such a IP packet is formulated, somehow that IP packet must be sent to BSC, to SGSN, SGSN to GGSN. GGSN will do the counting of that IP packet size. For example, he will count that IP packet size is 300 bytes, and after doing that counting, he will keep that IP packet into your PDN, packet data network. Okay, so that is the idea. Okay, so now, um, what is the advantage of having this GPRS network by bringing these additional components and letting the mobile equipment to connect to this PDN is this packet data network is now entirely covered. It is now 100% accessible. So you can connect it to any system that is available in the PDN. Um, Earlier case when this direct PDN connectivity is not available because mobile is not having a IP address. So, because mobile was not having a IP address, mobile as a system is not allowed to directly reach the servers present in the packet data network. Then how can mobile reach some of the PDN systems? Because these PDN systems are having ISDN number, and mobile is actually using his ISDN number and contacting the other computer just like a landline phone or a mobile phone, just like a ISDN user. We are not trying to establish any IP packet services with that computer other than just making a voice call with the help of this ISDN number. So mobile is not using IP address when it is interacting with some of the PDN systems with the help of ISDN. Similarly, when you are using your USSD services, gathering the information from the internet servers and storing into your USSD servers and getting that information is coming to you just like a SMS. To receive this SMS kind of information from the USSD server, mobile doesn't need to have IP address. Mobile doesn't need to have IP address. So you can reach some of the systems in the PDN even without having the IP address. You don't need to have IP address. But that IP address is not required only when you are bringing the information from the PDN either through your USSD server or you are trying to reach those PDN systems with the help of your ISDN, but you can reach only the systems which are having ISDN number availability. You cannot reach rest of the systems. So what is the condition for connecting to the rest of the systems that are present in the PDN? The only condition is any component who want to interact with any of the systems in this PDN, that particular system, it can be any system, that system must have a IP address. Only then it can generate IP packets and send it into the PDN. That IP packets will travel, and finally reach the particular server, and the server will be able to receive that IP packet and extract the application information inside that, and it can reply back in the form of IP packets. So any system, if it wants to interact with these PDN systems, the mandatory requirement is IP address. Because IP address is not available for the mobile when the mobile was in the GSM network, as MSC is not allocating any IP address, GMSC is not allocating any IP address. So there is no way mobile can generate the IP packets and send it into the PDN. So they have made special components called as SGSN and GGSN to deal with this kind of a connectivity and letting the mobile equipment connected to this packet data network directly by allocating a IP address to the mobile equipment so that mobile can generate the IP packets. It will be sending those IP packets from itself to BTS to BSC. BSC will forward it to SGSN. SGSN will forward it to GGSN. GGSN will count that IP packet size for its billing operation, and after counting the size of the IP packet, it will keep that IP packet into PDN. It will travel with the help of routers, and that IP packet reaches the destination system, and the destination system will finally act upon it, and will generate a reply for that IP data that you are generating, IP packet that you are generating. So the primary conceptual need for connecting to most of the PDNs is having a IP address, because all the PDN systems would be dealing with IP address mechanisms. They demand that you communicate with those components by using IP addressing. That's the criteria. So by introducing these new components, GGSN and SGSN, they are fulfilling that need of allocating IP address to the mobile device. With the help of that, you would be able to travel to the packet data network directly. Any questions, Sagar?
Sir. Actually, what should be present in IP packets? Suppose I'm searching for some data for the internet. So in that case, sir, what should be present in my IP packets? First one is source IP, and second one is my server, which one I would like to reach out. That server IP. In between that, the data should be there, right, sir? So what should be my data is here? I'm suppose I'm searching for the cricket info from my cricket server. So in that case, sir, how it is? I'm going to say what exactly they're present in the data portion of that IP packet.
Data portion will be typically what your application generates. For example, if you are using a browser for searching something, now your browser will be considered as application. Your browser generates some HTTP data, hypertext transfer protocol data. So whatever the question that you have typed in Google server, now it must be sent to Google server. So the text that you have typed in the Google search box, along with that data, it will add some more HTTP header fields to that, hypertext transfer protocol header fields to that. For example, you have typed some 40 characters, something you are searching on Google, you typed 40 characters. Along with that 40 characters, some more information will be added by HTTP protocol. Let us suppose that HTTP protocol added another 40 bytes. Your 40 bytes, that 40 bytes together, it has become 80 bytes. That 80 bytes of information would be packed into IP packet, and for that IP packet, source IP address is your mobile equipment, destination IP address is going to be Google server, which is present in your PDN, packet data network, and that IP packet will travel through this particular direction, and it will finally get into your PDN, packet data network.
Okay. Sir, in those days, DSCP are present or not, sir?
Sorry?
In those days, means when GPRS was
Introduced.
invented, in those days, DHCP are there or not? DHCP server.
SIP.
So DHCP is dynamic host to IP.
Actually,
Yes.
DHCP is very much required. Whatever the functionality GGSN is performing is just like acting as a DHCP server, because only a component which can act like a DHCP server can randomly allocate the required IP addresses for the mobile devices. So this GGSN is indeed acting like a DHCP server. All these things will be clear for you once you started listening to the OSI sessions. You have OSI 31 video sessions will be available to understand the IP technology completely, how these DHCP systems works out, etc., how DNS works out, how mobile equipment will know what is the destination server's IP address. So these kind of things, all those things will be explained to you in the TCP/IP OSI classes. So you have to listen to those classes to get complete idea on that. But because you asked the question, I'm telling you, GGSN is indeed your DHCP server in Gprs environment, because it
Okay,
is the
sir.
one who is
Thank you.
allocating the IP address to you. Typically, whichever system that allocates the IP address to a other machine, that will be called as a DHCP server. Typically, your router will be acting as a DHCP server in your LAN and allocating IP address to you. Because your router will be containing this DHCP protocol present in it, and it will be acting like a DHCP server and allocating you IP addresses. Similarly, in this GPRS environment, it is the GGSN who allocates the IP address to you. All right. Um, what you need to take away from the GSM GPRS architecture point of view? PSTN and PLMN are completely integrated with the help of ISDN, and you can reach any devices, any PSTN, any PLMN devices with the help of ISDN. But only a small portion of PDN can be reached through ISDN. So that means that there is lagging in the PDN. To be able to connect to the remaining systems present in the PDN, having IP address is mandatory. Having IP packets generating is mandatory. So to make those IP packets, to generate those IP packets, your mobile equipment must have a IP address availability. That IP address to be allocated by GGSN. But to convince GGSN to allocate your IP address, first mobile should convince SGSN. So SGSN will do all authentication, etc., etc. It will test you in from all the aspects. It will check whether your IMSI number is genuine or not, your IMEI number is genuine or not. It will check everything, and after you proved to be genuine in every aspect, then only SGSN will decide to accept the UE service. That time it will go and contact the GGSN. GGSN allocates your IP address, and then you start working in that particular GPRS situation. Okay, now what your BSc is going to do, we try to concentrate a little bit on the BSc. For example, we actually have studied the 51 frame architecture earlier. There are a lot of traffic channels that are present. All those traffic channels that are available are actually used for your CS operations. But if you wanted the same BSc to allocate the resources for mobile for PS services also, we need to evacuate some of those positions, some of those slots. Instead of allocating all the slots for CS channels itself, instead of it, some of the slots we must allocate it for your PS channels as well. So what do they do is, after introducing the GPRS, they will change the channel architecture. Instead of having only CS based channels, now we will be having CS based channels as well as PS based channels, and you have to make arrangements in your slots for both the type of channels, both CS channels as well as PS channels. Now when mobile equipment is sending a request to BSc, mobile will clearly explain the BSc. He is trying to make a PS service or a CS service. It will clearly specify that to your BSc. Is it for PS need or for CS need? Depending on that, BSc will allocate the required slots from the divisions. So if you request for PS, it will be allocating you from the PS division. If you request for if you are requesting for a CS, it will be allocating you for from the CS slots. So there is some kind of a division that is there going on. So once by getting the required slots, your mobile station sends the data. BSC's duty is to find out the data that is arriving from the mobile. Is it a CS-based data or a PS-based data? It can easily recognize it with the help of its own brain, and then it can forward that information to one of the two components, either to MSC or to the SGSM. So that's the kind of activity that would take place in Gprs. We are not going into the deeper slot level details on how the radio resource allocations are going to happen for PS services. We don't need to. As I told you, we have learned already enough. We are not going into that level right now. Great. The last topic that we have to study in the GPRS called as routing area update. So what is the meaning of a routing area? Just like how the cells are divided into location areas, similarly, for the purpose of PS operations, cells are divided into routing areas. So whenever mobile equipment is moving from one cell to the other cell, mobile would be monitoring what is the location area and what is the routing area. If mobile finds out that location area got changed, mobile must report it to MSC, explaining him that my location area got updated. But if mobile finds out that its routing area got changed, then mobile must be updating that to your SGSM. So SGSM would be maintaining mobile's present location in terms of routing areas. MSC would be maintaining mobile's present location in terms of location areas. If mobile gets an incoming CS call, circuit switched call, MSC would be searching for the mobile in the entire, location area where mobile equipment is present. But when the mobile is getting an incoming PS call, if you are getting a PS data or a PS call, that time SGSN will be searching for the mobile by using the same paging procedure, but SGSN will be searching for the mobile not in location area, but it will be searching it in a routing area. So that is the primary difference here between PS operations and CS operations. So a routing area also comprising of many cells, but in most widely implemented concepts, a routing area is always going to be either to the equal to the size of a location area, or inside a location area you will have multiple routing areas. But routing area will never be bigger than location area. That is how normally they will do the configurations. That means if a mobile moves from one location area to another location area, then we can clearly say that if location area changes, both location area changes, routing area changes. Both the things will change. Because if one location area is comprising two routing areas, if you are moving from one location area to another location area, you are changing location area as well as you are moving out of these two routing areas and you are going into some other routing area. So whenever you change a location area, you have to perform both location area update and as well as routing area update. But if the mobile did not change the location area, but still there is a possibility that mobile might change his routing area. Because in one location area, there are two routing areas present. If mobile moves from one cell to the next cell, mobile finds out that location area did not get updated, but routing area got updated, routing area got changed in the new cell. Then mobile will go and speak to SGSN and performs the routing area update. Okay, so there are two kinds of updates: a location area update and routing area update. Mobile must perform location area update with MSC, routing area update with SGSN, but it is completely the operator's discrimination or operator's intelligence to decide which cells would be present in which location area or which routing area. That is completely operator's decision. It is the operator's choice. So depending on what operator thinks he is the best, operator will be configuring the cells in terms of location areas and routing areas. So that's the idea that we have here. All right. That is your the routing area concept. Yes, Nishant.
Sir, Nishant here. Actually, I have just one question here. Actually, the location area is just like a LAC location area code, right?
Just the same concept, but a different component is maintaining it.
I'm asking because when we define a site, we define LAC, and in BCCH or the system information, the LAC
Yeah.
is
From
LAC is
system
transfer.
information only, mobile will find out what is the routing area or what is the location area. So you must read BCCH slots to find out the either the location area or the routing area. So if you, for example, let me tell you, if a cell is configured purely as a GSM cell, it doesn't support GPRS services, then only location area would be configured for that cell. But if a cell is configured for both the GSM operations and GPRS operations, now that cell must contain a location area code and a routing area code. So once the mobile synchronizes with that cell, read the BCCH slots, mobile would be able to find out what is that cell's location area and what is that cell's routing area, and depending on that it will be reporting it to corresponding service components. Mobile reports its location area to MSC, mobile reports the routing area information to SGSM.
Means you are saying that system information contains RAI location area, routing area also.
Yes,
But
both.
I have one doubt, sir. When we check in our mobile by net monitor or something else software, the routing area never shows there. Why it is so? Means LAC is showing, cell ID is showing, but routing area I never found in there.
If you did not find the routing area in a cell, typically means that the cell is not configured with GPRS operations. It is a pure GSM cell.
No, sir. Nowadays, every cell is GPRS supported in our network also. But in
You
system
have to
information,
look carefully. You will definitely find it. There is no way that you can escape from that. That information would be there for sure.
okay, okay, fine, sir. I will look into it.
Okay. Great. That is the end of our GPRS study. Okay. Now we are going to start with our next topic, which is going to be UMTS. So we have completed our GPRS quickly. Now we are looking into UMTS. Okay. So in UMTS, what are we going to study? First, we'll try to understand the difference between GSM GPRS architecture and UMTS architecture. Are there any differences? Now, if you observe this particular architecture that you are seeing in front of you is your GSM plus GPRS environment. It is having both the CS services as well as PS services. It is having both CS and also PS. So we have BSc, MSc, etc. Now, the moment you change to UMTS architecture, what is the changes that you observe is some of the interface names are getting modified and some of the component names have been changed. But only the changes that you are seeing here is below this portion. If you see above this part, nothing else gets changed. Only this side there will be changes. So just observe it when I'm sliding back and forth. So this is your GSM GPRS architecture. This is your UMTS architecture. So only some radio components have got changed. In place of a BTS, we have got a Node B. In place of BSC, we have got a RNC. And the interface names have got changed. What is the meaning of these interface names? What is the use of these interfaces and what is the meaning of the interfaces? Interface basically are just names. If you don't give a name to any interface, it will become little difficult for you to write the documents on this particular technology. For example, if you don't have this interface name, let us suppose between BSc to MSc, the interface name is A. We did not name it as A interface. Let us suppose every time that you have to write about this particular communication happening between PSC and MSc, we have to write a long statement on the interface between BSc and MSc, then put a comma, then start writing something. But when you give a name to this particular interface with letter A, you, how can you write the sentence in the document is on A interface, comma, then you start writing whatever the technical statement you want to write, you can write it. So for the easiness of writing the documentation, they found out that it will be better if you start giving one name for the link between two components. They have just somewhere, some places they have used some alphabetical characters, some places they have used some little expansions, etc., etc. But they have followed some kind of a notation, and they have decided the names. So, but now the components are changing. Radio components are changing, especially when it comes to the UMTS architecture. So interfaces are also getting changed. That means what is the primary difference between your GSM GPRS architecture and UMTS architecture is by introducing a better radio technology called as a WCDMA radio technology, we'll be able to send much higher speed data, higher quality of service we can achieve in UMTS network. So other than that primary difference, your core network side and everything else, there is absolutely no change. All the components have been continued as it is. So we have MSC, VLR, GMSC, all the HLR authentication center, AR, SGSN, GGSN, VLR, everything is same. All the ISDN, PSTN, PLM and PDN architecture, everything is perfect. Only difference is in the old technology, your radio resources were maintained by PSC, and PSC is using a modulation called as your MSK modulation. We are using GMSK modulation. We are using in GSM, and later some additional modulations have been introduced in Gprs and edge technology to increase the data rates by using the same number of same amount of radio resources. How can you send more amount of data, more bits? How can you send more bits? So that is your concept. But by the time we have come to UMTS, they have changed the radio technology to much better radio technology called as WCDMA. And in WCDMA radio technology, instead of using the slots, we use a concept called as codes, something called as scrambling codes and spreading codes we use. So any mobile who requests for the services, radio services, RNC would allocate either a scrambling code or a spreading code. In case of uplink, it will allocate a scrambling code. In case of downlink, it would be allocating a spreading code. So it would be allocating these codes. By using these codes, mobile will be transmitting the data by using CDMA technology, code division multiple access, where every mobile would be equipped with a mathematical orthogonal codes called as spreading codes and scrambling codes. So what is the meaning of mathematical orthogonality? How this whole operation will work out? Are we going to spend any time in studying that? Not required. We are not going to study any of that because it is again useless. We are only going to study UMTS for only for today. Tomorrow onwards, we start with our LTE technology, as we have already completed all the necessity basics. So of all the technologies. So the idea is not to study any of the technologies, any of the old technologies, only to gather the much needed higher level structure or the architecture of these old technologies. Okay, so every task that BSc was doing now done by RNC, almost every task that will be done by PTS would be done by Node B. There will be some technical changes, some radio changes and interface name changes, etc. happened, but remaining thing remains the same. So if mobile requires CS services, mobile need to beg those CS services from MSC. If mobile requires PS services, packet services, it must be requesting it from SGSN. So those concepts did not change. The work of any components did not change. GGSN is the IP address allocator. GGSN will do the billing, count the number of bytes of data that the mobile is sending, and then put the IP packet into the PDN. Or if the any downlink data is arriving from the PDN, GGSN will count the number of bytes and send that IP packet in this path. By following this path, we will send it to the mobile equipment. So the concept is absolutely same. There is no change at all from your GSM GPRS environment into your UMTS environment. Only your quality of service is improvised. You are getting lesser data rates in GSM GPRS. In UMTS, you can get much better data rates compared to GSM and GPRS technology. So that is the biggest change. That is the biggest conceptual change. Sorry. All right. Now, how registration happens in UMTS? We are talking about PS registration here. Why are we talking about PS registration here? Because we have already studied CS related things in GSM, and we have skipped anything that we have not discussed. Nothing is discussed in GPRS. So directly we study PS related things in UMTS. So in UMTS, we have a concept called as a GPRS attach. Okay, so what is the meaning of GPRS attach? Meaning is mobile equipment is attaching with the GPRS network, nothing but indirectly it is registering with the SGSN for packet services. We did not study this, uh, PS attach procedure in GPRS because I know that I'm already going to introduce that in UMTS. I have skipped that in while introducing the GPRS concepts. So mobile was in idle state, and you have activated the GPRS by enabling the data. So you have taken your mobile phone, you have enabled the data, you clicked that data button. The moment you clicked the data button, mobile will first go and talk to RNC, tell him that, hey man, I want to do a registration, and this particular registration I want to perform is with the PS network. It will explain that situation to your RNC. RNC quickly accept his RRC connection, and mobile will tell him a thanks. With these steps, mobile is coming into connected state. Mobile equipment have acquired the required radio resources needed for communication in the UMTS environment. So just like how your BSc is allocating SDCCH slots, here RNC would be allocating some codes, some WCDMA codes. It will allocate to the mobile. Hey man, you wanted to perform a registration. I'm going to accept, and I'm going to allocate you some codes, some WCDMA codes, by using which you can transfer your messages. So mobile prepares a signaling message called as attach request, which is a GMM message. stands for mobility management, which is related to CS. So if RNC sees that, if it is a message, RNC would have forwarded that to MSC if it is a message. But right now it is a GMM message. What is the meaning of GMM? GPRS mobility management. The moment when RNC sees that it is a GPRS mobility management message, and also mobile is exclusively mentioning that the core network domain I am dealing with is the PS core network. It has told, it did not tell that it is a CS, it is telling that it is a PS. So because of that, what immediately RNC is doing is RNC is forwarding this message to SGSN, instead of forwarding it to MSC, this attach request is getting forwarded to SGSN. So we are forwarding this attach request. What does SGSN do? As usual, SGSN will do the authentication and start the security mode, ask the mobile equipment to start the secrecy part. And after all the security steps are completed, then SGSN is accepting the attach. And by sending a message to your mobile that, hey man, I'm accepting your attach request. From now onwards, if you require any kind of a PS services, you are free to ask me. You can actually send that request to me, no problem at all. I'm accepting your attach procedure. That is what SGSN is conveying to the mobile. And at the same time, one interesting part is your SGSN will also um, allocate a SGSN would allocate a special ID to the mobile in this particular message called as it is known as PTMC. Even though it is not listed here, I am showing it to you. It is called as PTMC. So when it registers with MSC, Mobile Switching Center, MSC allocates mobile with a TIMC, Temporary Mobile Subscriber Identity. But when mobile registers with your SGSN, SGSN would be allocating packet TIMC. PTIMC stands for packet TIMC. So instead of mobile using the permanent number, SGSN is suggesting the mobile that from next time onwards, when you are going to talk to me, you don't need to quote your permanent IDs. Instead of your permanent IDs, you can quote this temporary ID that I'm allocating it to you. The PTMC number that I'm allocating it to you, you can quote it. Okay, so that I can recognize you and I can decide either to accept your services or reject your services. But you don't need to quote your IMSI number. Only first time you need to quote your IMSI number. Later you don't need to, because I'm already allocating you a temporary ID called as packet IMSI. That's the idea. And then mobile sends a attach complete, thanking the SGSN for accepting his attach procedure. So once the attach is successfully completed, SGSN speaks to RNC, and RNC removes all the radio resources, and the mobile would be moved back into idle state. But we can clearly say that the mobile is already, mobile already has completed his registration with SGSN successfully. After completing the registration, mobile has gone again back into idle state. For time being, as he is not using any packet service at this stage. Now, how the packet service will happen in UMTS? We have already studied end-to-end CS call, how a CS call will get established from one mobile to another mobile in a CS environment by keeping the MSC in the middle. How that whole thing happens, we have studied that part already. So we only need to study about the PS calls. These PS calls are actually called as PDP context. It is named as PDP context. Okay. What is the meaning of a PDU, SDU? Those terminologies I'll introduce in LTE. You don't need to worry about it. PDU stands for Packet Data Protocol Data Unit. It is NAS is the protocol protocol message that is generated by your mobile phone to send it to either your SGSN or your MSC. Okay, so that is the meaning of NAS. All those things you don't need to worry. Forget about everything. When we study LT, we study everything from expansions to all different things like that. Okay, so you don't need to remember those things now. Okay. So a PDP context. So your mobile user, human being, suddenly opened the application like WhatsApp and he started sending a message. Now, if you decided to send a message, first it need to go to WhatsApp server. Immediately, what your mobile recognizes is because this guy is using some application and generating some application specific data, that application specific data will be packed into IP packet. To send that IP packet into packet data network, I must take the permission from SGSN. Taking that permission is actually called as PDP context activation. You must go and speak to SGSN and ask him for activating your PS service. So, first, mobile is in idle mode. It will be requesting RNC for radio connection. Once the radio connection is established with these first three steps, right now mobile equipment is in UMTS connected state, one of the two states called as cell DCH or cell fetch. You don't need to understand what is the meaning of these things also. You can forget about it. But you can say that the mobile is in right now in connected state. Once the mobile is in connected state, mobile phone started sending a message to SGSN called as a service request. So it will convey to RNC that I want to talk to PS core network. So RNC recognizes that and forward this message to SGSN. This service request message, it will forward it to SGSN. Indirectly, mobile is requesting your SGSN that, hey man, I am so and so person who I have already completed PS registration with you earlier. When my user has enabled the data, I have registered with you. Now my mobile user is enabling a application and he would like to send the application data into internet. So now I want that service. Please provide me this PS service. So mobile equipment is sending such a message to SGSN. So what does SGSN do once it gets this service request? As usual, it starts the authentication and security mode. Your security procedures will be taken over after verifying that everything is good with the mobile. Then finally, SGSN is ready to receive the actual request from the mobile. So earlier, mobile has only sent a service request, but it did not explain to SGSN what kind of a service. Now, mobile equipment is explaining SGSN that I want to activate a PDP context because my mobile user is generating some application data which must be packed into IP packets, and I want to forward, I want to dump those IP packets into internet world, into the PDN packet data network. To do that, I wanted to activate the PDP context. So it generates this message and it sends it to SGSN. Now, what does SGSN immediately do? SGSN will ask RNC to upgrade the user's resources to traffic channels immediately, and RNC take up that activity and allocates the traffic channel resources to the mobile. Once that resource allocation is completed, um, you will be reporting it back to SGSN that, hey, to send that IP packets from the mobile, whatever the traffic channel resources we require, those traffic channel resources are already created. So we are informing back to SGSN. Once that is reported to SGSN, SGSN comes back to the mobile and tells him that, man, I have successfully activated your PDP context. I have already created, I have already allocated the required resources for you. I have already allocated you required traffic resources for you. Now it is the time for you to start transmitting your packet PDUs, your IP packets. You can start transmitting. You can do that job. Okay, so that is what is told to the mobile by activating the PDP. Now, in packet services, uh, only IP address must be allocated to the mobile at the time of activating the PDP context. So inside this message, that IP address details will be available, like what IP address is getting allocated to the mobile. That information would be present inside this message. And we are not searching for any other mobile phone here because packet data is a individual mobile phone's operation. Mobile phone won't be dealing with another mobile phone. You are sending the data to internet server. Uh, Internet server 24/7, it will be available in the packet data network. Once we allocate the required traffic channel resources for the mobile by using the traffic channel resources, it packs the IP packet digital data, the ones and zeros digital data. It will pack it into the radio resources. It sends it to RNC. RNC sends it to SGSN. SGSN to GGSN. GGSN will put it into internet. That is the idea. Just give him a minute, guys. Just hold on. Okay. So yeah. So that is the idea there basically, on the packet PDU transmission. Okay, so once you activate the PDP context, you will start transmitting the data. You start transmitting your IP packets. Basically, that is what will happen there. Okay, so you don't need to search for any other mobile. You once mobile requests it from SGSN, SGSN immediately upgrades you to the traffic channels, and it will tell you that this is your IP address. And once mobile get to know the IP address, mobile start generating IP packets and start sending those IP packets into internet. All right, so that is the UMTS introduction for us. Tomorrow, we are going to study how these IP packets will actually be sent from mobile equipment to internet. We are going to study that part in our next session. Okay, so first, once we study the IP packet traveling flow, we will get a complete idea on how this IP networking mechanism in the mobile phones work. Once we have that basic understanding, we start to learn how the LTE technology was introduced and what is the differences between UMTS and LTE. We start understanding that part. So in our next session, we will be doing some practicals to understand IP packet flow, and with that practicals, after the practical, we will enter into LTE basics, LTE basic classes.